Hello, I'm Jacob Cook, and this is my mechanical behavior of materials project, and for that I have chosen cast steel. The reason I chose cast steel is because it was the main material in many of the components of diesel engines at Cummins. I want to study cast steel and learn what are the good and bad properties of cast steel. I want to learn why cast steel is a good choice for manufacturing diesel engines. Where is cast steel used? Cast steel is used in many industries ranging from food processing to electronic to oil and gas. Some specific industries are transportation, construction, drilling, and mining. Processing of cast steel. Steel castings are solid metal objects produced by filling the void with molten liquid steel. Typically, cast steel is removed from the mold after solidifying and cleaning. It is then sent through a heat treatment process. The cast steel is then inspected for surface imperfections. These are the microstructures of cast steel. According to TotalMateria.com, ferrite has a choice of 3 different positions to form in based on supercooling or ease of forming nuclei. Figure 1, which is up here, this top one. Figure 1 shows ferrite starting to form at the grain boundaries, and if sufficient cooling time is given, a ferrite structure will form. Figure 2, which is the one here just below that, shows a faster cooling rate causing mesh-like arrangements known as the Weidmann-Satin structure. Figure 3, that's the very bottom one. Figure 3 is the Weidmann-Satin structure is fully formed. This is the microstructure of cast steel. This is what cast steel looks like under a microscope after the annealing process. Image A, which is this first one here to the left, is annealing at 700 degrees C for 10 hours. Image B, that's this one here in the middle, is annealing at 800 degrees C for 10 hours. Image C, this very last one on the right, is annealing at 900 degrees C for 10 hours. This shows the effect of temperature on the size of the grains. You can see as temperature increases, so does grain size. Crystalline structure of cast steel. In an article from MachineDesign.com, in the iron-carbon alloy system, an important phase transformation takes place between 1300 degrees and 1600 degrees Fahrenheit. The exact temperature is determined by the amount of carbon and other alloying elements in the metal. Iron transforms from face-centered cubic (FCC) structure called the gamma phase or austenite at high temperature to a body-centered cubic (BCC) structure alpha phase or ferrite at a lower temperature. In pure iron, this transformation, the A3 transformation, is marked by a distinct increase in length as the metal cools below the critical temperature. Because the body-centered lattice is less compact than the face-centered lattice, high temperature austenite and FCC structure allows enough space for carbon to squeeze in between the iron atoms. Iron atoms maintain their place on the lattice, and carbon atoms become interstitial. In the lower temperature ferrite or BCC structure, however, there is no room for carbon atoms. What happens to these carbon atoms determines many of the properties of iron and steel. And over here on the right is a chart demonstrating the effect of temperature on the crystalline structure, well, temperature and carbon weight. Material properties of cast steel. Cast steel can be produced with a wide variety of properties and are carefully selected based on the performance requirements of their intended application. According to RelianceFoundry.com, cast steel's physical properties rely heavily on its chemical composition and heat treatment. Cast steel containing a higher carbon content has higher strength, which means better hardness, giving it the ability to withstand abrasions. Lower carbon content cast steel has higher ductility, which gives the steel better toughness. Cast steel processing microstructure property relationship. Cast steel's strength depends largely on how its carbon atoms fit into the interstitial crystal lattice sites of the BCC arrangement of the iron molecules. The interstitial carbons make it harder for the dislocations to occur. Hot working causes dynamic recrystallization, which occurs when new grains nucleate at existing grain boundaries. Recrystallization depends on strain rate, temperature, and amount of strain on the metal. As strain rate increases, the amount of recrystallization increases. Cast steel processing microstructure property relationship continued. Cold working increases yield strength due to plastic deformation, which causes small defects in the microstructures of the metal. The defects make it harder for slip planes to move. Hall patch hardening happens during cold working, causing the grain size to reduce. As grain size reduces, ductility decreases and hardness increases. This increase in hardness is because the grain boundaries act as barriers to dislocation movements. Advantages of cast steel. Cast steel is very flexible to design with because the cast steel can be designed with complex shapes and hollow cross-section parts. Cast steel has the ability to have different chemical compositions to adapt to a variety of projects. Cast steel offers good weldability and workability. Cast steel can have a variety of weights ranges that are dependent on its cast size. More advantages of cast steel. Cast steel has a competitive advantage too. With short production times per part, it's affordable and economical. According to CastingFoundries.com, cast steel has mechanical properties that are superior to any other casting alloys, and a variety of high alloy steel for special purposes. Cast steel can withstand high tensile stresses or dynamic loads. Disadvantages of cast steel. When cast steel is compared to other metals, it has relatively bad shake suction. Cast steel does not have the best wear resistance. But as you can see, there's very few disadvantages to cast steel. Conclusion. With the advantages of cast steel, it is easy to see why it is the main choice of material for Cummins. It is easy for Cummins to create many kinds of complex parts from castings. Cast steel is relatively inexpensive, flexible, and durable, making it a great choice to make diesel engine parts. And this is my reference page from where I've gotten my information, and thank you.